What is going on, Year 11 General Mathematicians? Mr. Herman here, back at it again with part 2 of the 6G series. Lesson 8 this one will be. And this one is interpreting and analyzing the graphs of linear models. I'll move myself over there. So we look at graphs. We can interpret it, we can analyze it, we can not necessarily dissect information from it, but just observe information using the skills from the previous exercises. And we can use these interpretations to answer some pretty straightforward questions in relation to the context of what's happening at hand. These skills are particularly useful leading into Unit 3 and Unit 4 of further maths. So the start of this example here is pretty simple at the start, and then it goes straight into nitty-gritty in question D. We'll get to that in a second. For now, this is the graph of water being pumped into a partially full tank. It says here partially, and this is a key word to indicate that it's already got water in it at the start, and then the tank is going to be filled up with more water at a constant rate. This graph gives the volume of the water in V liters after T minutes. So after a certain amount of minutes, there's going to be a certain amount of liters more added to the tank, and this is going to keep going. By the looks of it, 18 minutes that we have here. So we're just going to answer the questions accordingly. Pretty basic stuff, things we have seen before. D will be a lot of the nitty-gritty stuff. And then from D, we're going to use the equation in D to answer E and F. So the first part, A, how much water is in the tank at the start? We can see here that at the initial time, this graph is reading up by each square or each section 200 liters, 200, 400, 600, 800, etc. So at this initial point here, we can see that this graph is at 200 liters. So how much water is in the tank at the start? There is 200 liters. At the start, I just try initially. First question, done. Very simple to interpret that information. Second one, how much water is in the tank after 10 minutes? So we look at the time on the bottom, on the horizontal, the t-axis, look at 10 minutes and map it out to the line to indicate that at 10 minutes is 1,200. So how much water is in the tank after 10 minutes? After 10 minutes, there is, and in this case, 1,200 liters. Very simple stuff. C. The tank holds 2,000 liters. How long does it take to fill? So now we're just doing the inverse of this. We're mapping out 2,000 and we're matching up to the time frame, which actually is the end of the shown time frame, 18 minutes. So how long does it take to fill? It will take 18 minutes to fill. And just remember that when you're answering this question, you can see that I'm putting it in worded or sentence format, very brief worded format. That's fine. I'm showing that I'm showing the question indirectly through my answer. So it says here, how much water is there in the tank after 10 minutes? I've just written after 10 minutes, and then I'll explain my answer, or what the answer is. So it's easy to do that rather than writing a paragraph for your answers like we've seen in some of the previous questions. And also be mindful that I'm also including my context here. So liters, minutes, depending on what your variables are, should dictate what or how you answer or what you put within your answer. Okay, so you just can't say it will take 18 1. Okay, and so in this case the time frame is in minutes, so you have to write 18 minutes. It's okay to do shorthand notation in this case. Question D. Whoops. And this is where we get into the nuts and bolts of the question. Find the equation of the line in terms of V and T. So in other words, we want to know how much water will be in the tank in volumes depending on what time frame we have been given. Or in other words, V is equal to A plus BT, and the two variables we're looking for, B and T, the initial and the slope. Okay. Now in previous exercises, we know how to work out this skill using the graph. A is very simple. If the graph shows you where that Y, or in this case where the V intercept is, and likely enough this is shown within the question. So we can find A, and we just know that A, the letter A, not the question A, the letter A is equal to where that initial amount is, so it's 200. Okay, so A is equal to 200. I don't need to write L in this case because we're just finding a numerical answer to put into our equation. Okay, so we're not showing the worded context of this part yet. Okay, so A, however, in this case, if we were writing equations, so A is equal to 200. To get our B, we're gonna find our y2 minus y1 over x2 over x1. But to be consistent, I'm going to use V and T. So V2 minus V1 over T2 minus T1. Nothing different about this gradient or slope formula other than the fact that instead of Y's and X's, I'm using V's and T's, okay? Just to keep the context the same. If you write y2 minus y1 over x2 over x1 and it's showing volume and time, that is okay only within your working out. Okay, but the question specifically said, and you've got to be careful, find the equation lines in terms of V and T, in terms of. So you have to answer in V and T. I'm going to keep it consistent, so I'm going to use V and T. Now, I'm going to choose my two different points. So one and the other. So I can use my initial one. So when time frame is equal to 0, our volume is 200, and when the time frame is equal to, let's use 10, we use 18, we can use 10. When the time frame is equal to 10, the volume is equal to 1200. Whatever 2 points, it does not matter what 2 points you use, as long as they are on that line, because if you use any 2 points, you will always end up getting the same ratios, okay, or the same gradient. Assuming that you use the correct points within that line. Here we can visibly see that the line is going up really consistently and it's hitting every single blue line intersection. So I can use any 2 points within that line. I can use those two, that one and that one, it does not matter, okay? So this is gonna be my T1 and my Y1, and this is gonna be my T2 and my Y2. T2, oh my goodness, see, I just made a mistake myself. T1, V1, get it together, Mr. Herman. T2, V2, much better, there we go. All right, let's do our substitution. Our V2, 1200, subtract V1, 200. So the difference within the volume, so we're looking at that difference here. How much does it differ by from bottom to top? And over T2 minus T1, so our T2 is 10 minus T1, which is 0. In other words, what is the difference in time frame from here to here? Of course, it's going to be 10 minutes. From 0 to 10 takes 10 minutes. So let's add to this. 1200 take away 200 is 1000. 10 take away 0 is 10. Neat little trick if you're dealing with dividing by tens and there are other zeros, just cancel out the zeros. This is the same as how many ones go into 100. 100. don't feel confident with this step, you can always just do 1000 divided by 10 within your calculator. And now we have got our B value. Now, in other words, this is getting filled up by 100 liters per minute. So for every minute that goes by, we're filling it up by 100, every minute 200, every minute another 100, every minute 100. I said 200 before there. 100, 200, 300, 400, 500, 600. That's what I meant. It's filling up by 100 liters. So to answer the question, the volume is equal to 200, because that's our initial point, plus 100 T. There's our initial point right here. That's our rate, how much it's going up by. And we're going to use this equation to answer E and F. Use the equation to calculate the volume of the water in the tank after 15 minutes. So with E, we are going to find volume, find V, when our time frame T is 15, and this is just a straightforward substitution. Again, you can check the graph at 15 minutes, which is here. The amount of liters is going to be 1,700. This is just based on mapping out there to there, so 1,700. And let's just make sure that this set of maths does us correctly. So our volume is equal to 200 plus 100 times 15. Always work out your multiplication first. 200 plus 1,500, and that's equal to 1,700 liters. So that is correct. So let's make sure we answer this in worded format. There will be 1,700 liters in the tank after 15 minutes. And then question F, sorry. At what rate is the water pumped into the tank? Now, this is very simple because we know what our slope is. We know that number in front of the T will dictate our gradient, our slope, our rate of change. So we need to be careful with this answer because we know that numerically it's 100. So we will say the tank is being filled at 100 liters per minute. Now, what I was saying before is the important part is this here, and specifically that rate. The question is asking for a rate, okay? What is the rate? And what rate is this water being pumped? So you have to answer this as a rate. You can't just say the tank is being filled at 100 liters. That doesn't make sense, both mathematically and English-wise. You can't just say, the rate is 100 liters. 100 liters per what? So you're going to say that it is 100 liters per minute. So that little slash there means per. You can also write 100 liters per min. That's fine. As long as you show the rate in either of these ways, you will get the required marks for your questions, okay? So be careful. If it's asking for a rate, answer in a rate. If the question said, how many liters are being pumped into the tank per minute, that's when you then can answer 100 liters without the rate section or part to it, okay? We're now going to look into the second example. Give me 2 seconds, guys. I'll just go set that up. The second question is looking at an example with a negative slope this time. So from left to right, the graph is reading downwards. So the value of a new car depreciates with time. The graph shows how the value V in dollars of a new car depreciates with time, in time. So we've got a value, dollars, and we've got a time frame, which is T. Same concept, but just this time it depreciates in value. So we're going to be looking at value, that goes down in time. So there's going to be a pesky negative that appears somewhere. We'll have a look into this in a second. So the first question, what is the value of the car? What was the value of the car when it was new or when it was first bought? Now this one's a bit tricky because it's not obvious because it doesn't lie within an actual specific value that's told to you on the V-axis. So it lies in between 2500 and 3000, So the value of the car, is $2,750, as this is the value that lies in between 25,000 and 30,000. Next question, B. What was the value of the car when it was 5 years old? So we're now expecting this value to be lower than what it initially was because it's now going down in price. So at 5 years, the time frame 5 years, the car's value, the value of the car after 5 years will be, and again, just matching it up to where it hits the 5 years, remember the context, $15000 or $15,000. Now, realistically, when car prices depreciate, they don't depreciate in a nice linear fashion. They tend to depreciate, and as time goes down, it depreciates faster and faster, and the rate increases in regards to this. So the older the car, the more likely it's going to depreciate down in price. So you might see a spike of it going down, and then it will remain at this consistent low price. This is called decay, if we're talking about in math terms. This right here, because it's a nice linear fashion, it's not a realistic approach, but it's what some people tend to use. Okay, so a bit of a little world fact there, tying maths to the real life world. Question C, find the equation of the line in terms of V and T. So nitty gritty, we're looking for V is equal to A plus B T. Same letters, coincidentally, different contexts, value and time, as opposed to volume and time. Time's the same, but it's not minutes, it's years this time, no pun intended. So our A, again, has been already figured out because it's the initial. So our A value in this case, that initial 27500. And then our B value is this V2 minus V1 over T2 minus T1 business. Find the two values of V and T. I'm going to put them up in the side here. I'm going to put one here, and I'm going to put them, just leave a little bit of space because we are dealing with bigger numbers. Let's use maybe this point here and this point here. I can use any 2 points again, it doesn't matter. So when our time frame is equal to 1, our value is 25000. And when our time frame is equal to 5, which is the 5th year, which we did answer. Whoops, no commas, no commas. When you put in coordinates in, don't put commas. I think I said this in the previous video. It makes it really confusing because we use a comma to indicate two different coordinate types, X and Y, or T and V in this case. So I just had a tricky habit, try to get out of it. So T1 and V1, T2, V2. we are expecting a negative slope. So we're expecting a negative to appear in one of these, in either numerator or denominator. Traditionally, it's the numerator. V2, 1, 5, 0, 0, 0, take 2, 5. There's our negative. We've got a smaller number, take away a bigger number. T1, 5, take away 1. Time difference is 4. Value difference. Let's work this out. Yep, equals. So 1, 5, 0, 0, 0, take away 2, 5, 0, 0, 0. What I tend to do is, when it comes to negatives, if I know it's going to be a smaller number, take away a bigger number, I automatically know that the answer is going to be negative. Okay, and then what I do is I swap the numbers around to just make it easier. 2, 5, 0, 0, 0, take away 1, 5, 0, 0, 0 is 10. 0, 0, 0. But because I know the answer is negative, I've already got that negative there. Okay, so it's just a little hack if you get stuck with doing negative or subtraction of a smaller number, take away a bigger number. You know your answer is going to be negative, and just swap the numbers. If I take 1 is 4. How many 4s go into 10,000? That is, or negative 10,000 rather. That is negative 2,500. So as the years go by, this car's price is depreciating or going down by 2,500, and that's what that little negative means. It's going down in price. And this is why negatives are actually important now. You can see the usefulness of negatives within the maths world, because negative gives us some context to the maths. It's going down, it's being subtracted away, and it's going to keep subtracting to the point where the price is going to be 0. So let's get it in the form of V is equal to, we know what our A is, 27500. Because it is a negative slope, we're going to take away 2500 and multiply it by our time frame in years. You give me a time frame in years, I can tell you how much the price of the car will be within a certain interval, of course. Obviously, we can't get a time frame of 90 years, because this will then indicate that the value of the car is at its negative. So people will be giving you money to try to sell it, which doesn't make sense. So you're also going to be careful within the time frame. Question D, at what rate does the value of the car depreciate with time? That is just the slope, which we've already found, 2500, making sure that we take into consideration that negative. So D, so to answer this, let's go back to the question, at what rate does, and remember it is a rate. At what rate does the value of the car depreciate with time? The car depreciates at, now the fact that we've said depreciates is showing the some form of negative. So you can say the car is going down in price, the car is losing value at, as long as you have the context of the negative, you don't have to write the negative symbol within your answer. Okay, so the car depreciates at $2,500 per what's the time frame? Year. So it's per year. Okay, the car depreciates. Even if you say the car is going down at, okay. And the last question, I'm just going to put here E. The last question, when does the equation predict the car will have no value? So when is it going to equal 0? So in other words, when we write our equation, V is equal to 27500 take 2500t, we want to define the time frame t when the value v is equal to 0. So we're looking for this when the value is equal to 0. So if I substitute that value into the equation, what we end up with is a 0 is equal to 27500 minus 2500t, and we'll notice that we've only got one pronumeral, one letter left, which we're going to solve for. Okay, you can use your calculator, or you can use your algebraic arithmetic skills and transpositioning skills. If a calculator is allowed, you might as well use it. So I'm gonna go ahead, grab my class pad calculator, and I'll show you the method. If you don't know how to do this yet, it's just using the solve function. Go into main, and you can see the solve that's being used in the previous previous example. We want to put it in standard format. Okay, so let's put in, actually I'm not going to put in solve, I'm actually going to show you via the keyboard, because you don't have the function of just typing in solve. There we go, solve. So it's in math 1, go into solve, and we're going to just type in this equation as is. 0 is equal to 27500 minus 2500 times, remember my times, oh my goodness, what do I do, what do I do? Take 2. I could just edit this out, but now I'll keep it in. I think my trackpad, I accidentally used a trackpad to skim it across. 2500 times, I'm going to just use x, it doesn't matter, as long as I answer within the right context, comma, I forgot, 0 is equal to that. Remember the comma and x, so we're just solving for x. So our x is equal to 11. Well, in other words, let's get rid of you now. In other words, when the car's price will hit $0 at after 11 years. Let's backtrack, because we want to sound fancy. It is predicted, here we go, it is predicted that the car's price will hit $0 after 11 years. And that is that question done. And that is the end of this video. Pretty simple stuff, just taking real life context into linear modeling. Now remember that these aren't true representations of how rates work. For water pumping, it actually is. This is a true depiction, because the pumping is consistent. But depreciation of a car, not necessarily. I've seen some cars modeled in that way, but realistically, it's not that approach. But in saying that, the maths behind it, the context behind it is very, very simple. As long as you know how to interpret that graph, you will be fine. As long as you get your initials, you get your slope, you know where to put it into your equation, and then use that equation to answer the questions. You'll be fine. This is me signing off. I'll see you guys in the next episode of 6G3. Catch you then. Now I've got to do the awkward thing of actually taking my... It looked better in my head.